Well, hello, iM3 classes. Today we are talking about rational and irrational numbers. Okay, what you're going to need to get is your packets out. I'm going to go through the notes for 7.4 day 1, and then at the end of this, you're going to go ahead and work on your Go formative that is linked in Google Classroom for you. So here we go. When we talk about approximating square roots, so that's really what we're talking about. We're talking about two different numbers. We've got rational numbers and irrational numbers. Just like rational numbers and irrational numbers, you can have rational people and irrational people, or rational thoughts and irrational thoughts. Rational is a number that can be written as a fraction. So it could be a fraction, it could be a terminating decimal, so a decimal that ends, like 3.5, or it could be a repeating decimal, so like 3.9999999. Okay, so that's also a terminating, or that's a repeating decimal. That's also a rational number. Fun fact, anything that repeats is always over 9. So if it's 0.44444, that's 4 nines. So just so you know that. An irrational number is a number that can't be written as a fraction. It's a number that's hard to work with. So a rational person is somebody that makes sense. So numbers that you can put in fractions, they make sense. You can work with them. You may not like them, but you can work with them. An irrational number is the same thing as like an irrational person. They don't make sense at all. It's not somebody you can work with at all. Okay? It's a decimal that never ever ends. So for example, pi would be a great option for an irrational number. Okay, so all we're going to do here is we're just going to label these with an R or an I for rational or irrational. Okay, so let's start thinking of the square roots. The square root of 225. Well, I know the square root of 225. You may not remember it, but we know that that's going to be a rational number because that's a number we can work with. 8 ninths, that's a fraction, so that's going to be rational. 1 over 21, again, that's a rational number because it's a fraction. And the square root of 13, ooh, I don't know that one. So I'm going to say that's going to be an irrational number because what's going to happen is if you actually put it into your calculator, when you put it into your calculator, it's going to end, but it really goes on and on and on. It doesn't end. So the square root of 5 over 17. Now remember, we can split that up into the square root of 5 over the square root of 17, but I don't know either of those as square roots off the top of my head, so that's going to be irrational. Now the square root of 49 I know is 7, so since 7 is a number I can work with, that's going to be rational. 3/8, that's a fraction, so it's going to be rational. And then when I have the square root of 121 over 169, again, if I split those up, remember that's going to be 11 over 13, which is a fraction, so that is also going to be rational. So I really only had 2 irrationals when I'm working here. Okay, now if we keep going, so for number 3 and number 4, 360. Well, remember we talked about decimals, and I know the square root of 36, but I don't know the square root of 360. So that one, again, is going to be an irrational number because I don't know that. I got a fraction, which means it's rational. I got a fraction, which means it's rational. Square root of 15, I know the square root of 16, but 15, not so much, so that one's going to be irrational. Working on number 4, take a second and pause the video, and then I want you to try to go ahead and go through all of these on your own. Then I'll tell you the answers. So pause it now. Okay, now that you're back, we're going to go back through these. Okay, well, this is a fraction. Even though it's a mixed number, it's still a fraction. It could be, an improper fraction. It could be written as an improper fraction. So that's going to be rational because it's a fraction. Ooh, 0.35. So 35 hundredths can actually be written as a fraction. Since it ends, it can be written as 35 over 100, which can also be reduced. So since it can be written as a fraction, it's rational. You see how the 3 just repeats? That's actually just going to be 3 ninths. So that is going to be a rational number. And even though it's negative, that 9, we can work with that. So it's going to be rational as well. All right. Next group. Okay, square root of 156. Think really hard. I don't know that one. So again, that's going to be irrational. Ooh, cubed root of 27. Now, if you think back to what we learned, we do know that one. That is 3. So I'm going to go ahead and say that that one is rational since 3 is a number I can work with. All right, the cubed root of 6. Now we know the cubed root of 8, which is 2. We don't know the cubed root of 6, so that one is going to be an irrational. The cubed root of 512. Now I know the square root of 512. Do I know the cubed root of 512? You actually don't know that one, but I will tell you that the cubed root of 512 is 8, and the cubed root of 1,331 is 11. That one does work out as a fraction. We'll make sure that the ones that you have work out even for you. Pi. Pi was one of those numbers that I said it doesn't repeat, so that's going to be an irrational number. Negative 1.22345 It's not repeating. It has that dot, dot, dot at the end. You're right. It's irrational. 1, 2, 1, 2, 1, 2. That one repeats. So that one is going to be something we can work with. That's going to be rational. And then 1.509. It doesn't have the dot, dot, dot at the end, which means it's going to be something I can work with. Okay. So we're going to go through now, and we are going to circle. Again, this would be a great time to pause your video. See if you can do this on your own. Hey, I'm back. So I went through number 7, and I said irrational. Which one is irrational? Well, it's the one that doesn't stop or repeat. Okay, so it has to be C. Then I go through and I say, okay, well, which of the following on number 8 is rational? Well, the only square root I know is 64, which is 8, and I don't know how to solve that last one because we don't know what number it is. It doesn't end. When I look at number 9, terminating. Remember, terminating is a decimal that ends. I'm going to tell you that if you have a dot, dot, dot at the end, that's never going to end. If you have a square root of something you don't know, that's not going to end. So we're down to the 2 fractions. You can take 7 divided by 8 and 5 divided by 11 on your calculator to see which one works out. But you also know, since I told you that 9 was just a repeating number, 11 is also one that's a repeating, except in this case, it's 2 digits that repeat, not just 1. Okay, now when we talk about approximating square roots, what I'd like you to do is you want to find the numbers that are the closest. So we're going to write this down. Okay, so when we are approximating square roots, we need to do 2 things. We need to find the 2 numbers surrounding your roots, and you're going to choose which one is closer to your number. Then you're going to estimate the decimal. And so we're going to do that first. So if I go down below, it says, without a calculator, estimate each square root. Well, I don't know the square root of 28. Let's see, I know the square root of 16. No, that's 4. There's got to be something bigger. 25. Yep, I know the square root of 25. And so that's 5. And then the square root of 6 would be 36. 28 is going to fall right in between those. But it's actually going to be closer to 25, which is 5. Which means that it's going to be probably around like 5.2, 5.3. If I pull out my calculator, I would do the square root, and I do the square root of 28, and I actually solve it. It is going to be 5.29 or 5.3, so I was really close with that estimation. So 100. Oh, I know the square root of 100, 101. So I know the square root of 100, and 11 would be 121, right? Which means that that 101 is going to be right in there. Let's just say 10.1 is probably going to be as close as I can get because it can't be just 10.0. So that is going to be my estimated one for that. Okay, so when I talk about 48, let's see. I know 6 is 36, and I know that 7 is 49. Oh, 48 is going to fall close to that 7. So it can't be all the way to 7, but let's just go ahead and estimate 6.9, and it's going to be really close. And finally, for 89, let's see, what goes around it? I know that the square root of 81 is 9, and I know the square root of 100 is 10. So I have to think in here, 89 is probably going to be a little bit closer over here. It's close to the middle. Let's go ahead and say 9.4 on this one. And you can always double check it, especially when you're doing your homework. just to make sure. Oh, look at that, 9.4339, so we were really close on that one. All right, so when we compare, so go back up to the top, and it says, how do you compare and order numbers? You can either put them both to square roots, or both, solve both, then compare. So if I want to already have one as a square root, and I could do 100, so I could do the square root of 20. Well, I could estimate that. Let's see. Square root of 16 I know is 4, and the square root of 25, so it's going to be right in between there. So it's going to be like 4.5 or 10. In that case, 10 is going to be bigger. The other way I could do this is, remember, to go from square to square roots, I just need to square them. So 2 times 2 is 4, 3 times 3 is 9. So the square root of both of those would be my fraction. Well, the fractions are not very nice, are they? Ugh. So I could go, let's see, let's try to put these back down. So that's going to be 4/9, and that's going to be 2/3. Well, if I find a common denominator, let's go ahead and get rid of this, because that's not helping me. If I find a common denominator with my fractions, because that's how we compare fractions, 9 is going to be the common denominator. So 3 times 3 is 9, which would make 2 times 3, which is 6. So then I look at the top, the numerator. What's bigger, the 6 or the 4? Well, it's going to be the 6 in this case. So I can go up. So I could actually go up to the square root of 100 on here. And so I can look in the square root of 100 and the square root of 20. Which one's bigger? Those are a little harder. You have to choose which is better for you. It might be easier just to bring them down to regular numbers rather than squaring both. Okay, so then this is when you use your calculator. So it says use the screenshot provided to answer the following questions. So the nearest tenth. Now remember, tenth is the place right after the decimal. So if I look at the square root of 10, it says it equals 3.1. Ooh, that's actually not true, because I have to look at the number behind it. So since the 6 is above 5, that should actually be 3.2. Okay? Then it says the value of the square root of 14 is between 3.74 and 3.75. That is true. Ooh, the lines got connected there. And then it says the square root of 10 lies between 3.1 and 3.16 on the number line. That is going to be false, because it does go so it's 3.10 and 3.16. That's going to actually be bigger, so that one is going to be false. And we're going to go ahead and put a false at the first one too, because that one was false as well. Okay, and finally we've got some number lines. We are going to go ahead and hold off on the number lines until tomorrow. What I'd like for you to do is you're going to go to Google Classroom, and you're going to go ahead and do your formative, or your Go Formative, to show us that you watched this video and that you're kind of understanding. Use your notes to help you. Have a great day.